Greetings, ladies and gentlemen. Thank you for joining me this morning. The returning viewers, thank you. If you are coming across this channel for the first time, thank you for joining me. In today's presentation, we continue with our solutions to senior school certificate examination. This is mathematics. This is NECO 2024. This is paper 2, part 2. With us here is question 8. In my previous video, I've solved question 1 to 7. This is question 8 with us here. Question 8 reads, a cone has a radius of 10 centimeters and a slant height of 26 centimeters. We are asked to find Roman numerals 1, the total surface area, correct 1 decimal. Roman numerals 2, volume of the cone, correct to 2 decimal places. Roman numerals 3, angle of the sector that form the cone, correct to the nearest degree. And this question carry 12 marks. First thing to do is to identify this question is from which topic. Of course, this is from a duration of solid shape. A cone is a solid shape. Let's look at how we can solve this together. Let's write down the solution. Write down the solution here. For us to solve this problem, we have to recall the relationship between a cone and a sector. When a cone is bent, a sector is formed. The slant height of a cone before bending, when bending, becomes the radius of a sector. Okay, so let's draw a cone. Let's say we have a cone this way. We have a cone like this. Let's say this is our cone here. We have the vertical height here, and this will form right angle triangle. This is the vertical height h. This is the radius. From the question, the radius is 10 cm. That's 10 centimeter. The slant height is 26 centimeter. Okay. When we bend this cone, we'll get what we call sector. So we have something like this. This will be our sector. Then this will be the angle that the sector will form. Okay? Then the slant height of this cone will become the radius of this sector, which is 26 centimeter. 26 centimeter. There's a relationship exists between this cone and this sector. Okay? The length of this arc here is theta divided by 360 degree times 2 pi capital R will be the same as the length of this circular cone here, which is the perimeter of this circle, because the circular base of this cone is a circle. So the perimeter of a circle is 2 pi small letter r now. Okay? So let's look at the relationship that exists between this sector and a cone. Okay? So from here, we can divide through by 2. This 2 will divide 2 to be 1. Again, we can divide through by pi. At the end of the day, the radius of a cone now, r, small letter r now will be the angle formed by the sector multiplied by the radius of the sector divided by 360 degree. So this is the relationship that exists between a cone and a sector. The first question, we are asked to find the total surface area of this cone. So let's write down the formula. Total surface area of a cone. Total surface area of a cone now. That's Roman numerals 1. Total surface area, that's Ssce of a cone, will be the curved surface area of a cone plus the circular base area, which is the area of a circle now. So this is the total surface area of a cone. We know our radius of that cone as 10 cm, the slant height 26. So we can easily find the total surface area. So TSA now will be pi is 22 divided by 7 multiplied by the radius, which is 10, times the slight height, which is 26, plus pi is 22 divided by 7 times 10 square. That's the radius. So we can use our calculator to resolve this. Okay, so let's look at how we can get that done. So total surface area now will be equals to, let's multiply 22 by 10 by 26. 22 times 10 times 26 divided by 7 we'll have 1871.1429. Let's leave our answer to 4 decimal at this point now. Plus 10 square is 100. 100 times 22 divided by 7. That will be 314.2857. So total surface area now, we can add now to get the total surface area. We add this, that will be plus 817.1429. Let's add 817.1429 plus 314.2857. We'll have 1114.4286. First question, we are asked to give our answer to 1 decimal. So let me remove the question so that we can do that. Finally, the total surface area to 1 decimal place would be 1131.4 cm squared. So this is the total surface area of a cone. Now that's Roman numerals 1. Roman numerals 2, we are asked to find the volume of a cone to 2 decimal places. The volume of a cone V will be 1/3 volume of a cylinder, which is pi r square h. But in this case, we don't know our height here, so we have to find the height of this cone. Realize that this is a right angle triangle. We can apply Pythagoras rule to find this height h here. Okay, so to do that, we realize that the slight height here, this is the hypotenuse, which is L squared, will be equals to the h squared plus the base radius, which is r squared. Pythagoras rule states that in a right angle triangle, the square of the hypotenuse is equals to the sum of the square of the other two sides. This is how we come about this formula. L squared now will be equals to h squared plus r squared. Okay, so let's look at let's move here to find h now. Since we know our slant height, the slant height is 26. This will be 26 square now, will be equals to h square plus the radius is 10 square. So 26 square is 676, will be equals to h square plus 100 plus 100, because 10 square is 10 times 10, which is 100. So we can collect like times here. 676 now minus 100 will be equals to h square. Okay, let's clean this to get the value of the height, the vertical height now of that cone. Okay, 676 minus 100, 676 minus 100, that will be 576, will be equals to h square. To do away with this square, we take the square root of both sides. Take the square root of both sides. H now will be equals to, this will take care of this. Square root of 576 is 24. So the height of that cone is 24 cm. That's the vertical height. We can easily find the volume because we know the radius of that cone as 10 cm. The height now is 24. So the volume V now will be equals to 1/3 times pi 22 divided by 7 times the radius, which is 10 square, times the height, which is 24. Volume V now will be equals to, we can multiply this. 10 square is 100. That will be 22 times 100 times 24 divided by 3 times 7 is 21 divided by 21. Okay, let's do it again. We have 22 times, that's 22 times 100 times 24 divided by 21. We'll have 2514.28 2857 2857 2514 2.2857 to 2 decimal place. The volume V now will be 2514.29 centimeter cube, because volume is measured in cube units. So this will be the volume, 2514.29 cm cube. So this is the solution to Roman numerals 2. Roman numerals 3, we are asked to find the angle formed by the cone, by the sector, the angle, which is theta now. So we use this formula. Let's move here to do that. Okay, so we use this formula now, the relationship between a sector and a cone. This r here is the radius of the cone. This theta here is the angle that the sector formed from the cone. Then the r here, capital R here, is the radius of the sector, which is the same thing as the slant height of a cone. So from the question, our radius r, we are solving Roman numerals 3 now. From the question, our radius r, which is small letter r, is 10. This will be equals to theta, that's what we're looking for, times the capital R, which is the radius of the sector, is 26, divided by 360 degrees. At this point, we can cross multiply to find the value of theta. 360 degree times 10, that will be 3600 degree, will be equals to 26 theta. We're looking for the value of theta. And the coefficient of theta here is 26. So we divide both sides by 26. Divide both sides by 26. Theta now, which is the angle formed by a sector from a cone, will be 3006 divided by 26. That will be 1138 rather 0.4615. We are asked to leave our answer to the nearest degree. Theta now to the nearest degree will be equals to 138 degree. That is to the nearest degree. The answer is 138. 138 degree to the nearest degree. So this is the solution to Roman numerals 3. The angle formed by the cone now, by the sector rather, when you bend that cone, is 138 degree. So this is the solution to this question. Thank you for watching. Please do share this to your learned colleagues, and don't forget to subscribe to my YouTube channel for more interesting video. In my next video, God's willing, I will solve question 9, question 10, 11, 12 in that order. Thank you for watching.